Hello, hello, hello. Good afternoon. Everyone having a good day? Yeah? My name is Jeremy Rossback. I am with Broadcom. Been there for the last 17 years. We were acquired by CA Technologies. Broadcom acquired CA Technologies in 2018. And I'm here to talk to you about the top 5 ways to simplify network consolidation and modernization. We're all very well aware of the modernization, data center modernization and network modernization projects going on. And I do believe that there are certain ways and rules and methodologies to be able to find the success in that, and we're going to talk about that today. Real quick, a little bit about myself. I was running data centers for the likes of Northrop Grumman, Department of Veterans Affairs, T. Rowe Price in Baltimore, if anybody's from that side of town. So I spent the first half of my career running networks, and I learned a lot, and I took that into my evangelist role here at Broadcom. And it's been very helpful to talk to customers like yourself and to understand their headaches and their challenges, as I had the same ones many years ago. So I find it odd, maybe it's just because I've been working for Broadcom for so long, that a lot of folks don't know what Broadcom does. If you have an iPhone, you got 4 chips, Broadcom chips in your iPhone. I'm sure most of us have navigation systems in your car. It's powered by Broadcom chips. Wi-Fi, powered by Broadcom chips, et cetera, et cetera. And as you can see, there's not really a data packet on the internet that doesn't pass over. Why is this doing that? Sorry about that. Not passing over our technologies. We have many data centers out there today utilize Broadcom chips, some of the fastest chips in the world, to push the largest amount of data across the internet. So really, Broadcom is in every side and every piece of the internet and many networks out there today running it behind the scenes. While this is a civilian use case, it does really compare to a similar large agency that manages many of the WAN circuits for the military and the government. Verizon Communications offers a managed service offering for the WAN circuits that they provide to the enterprises out there today. To be able to understand exactly the throughput, the capacity, any data loss, jitter, latency that is happening for these organizations, we're talking tens of thousands of WAN circuits out there that is managed by our solution from Broadcom today. So some of the largest networks out there use our solution for network observability and to modernize their networks. All right, so let's talk about the challenges that I believe are very inherent in any network operations center today. So, you know, the last 4 years, 5 years, give or take, have really changed the way our networks run. When I was running networks, it was a data center, it was a T1 to a branch office, set it and forget it, and wait till something breaks. It was kind of a cake job. But unfortunately, as we utilize and move workloads out to the cloud, use the internet and other cloud providers, SIPR, NIPR, et cetera, it really changes the way the network path looks for application usage out there today. It's not just a few hops. It's a lot more. It's public providers that you don't have access to understand how they're delivering your communications and your experience because you don't own that part of the network path anymore. As we utilize more SaaS applications, of course, that creates network blind spots for our network operations teams. Again, they are not the gods of every single hop, every single route, every single device in the network anymore. It is a shared network that we utilize to deliver customer experiences today. Anybody deploying SD-WAN or familiar with SD-WAN? So this is a new software-defined technology that helps to automate and make WAN circuits a little more resilient. Automated routing, we're going to route this over this more resilient path versus this one. But like any new technology, software-defined technologies can create a lot of noise. And no offense to Cisco here, but Cisco ACI can produce 23,000 events inside the network operations center today. And I don't think any operator wants to be sifting through 23,000 events to try to find the root cause of issues in their network. And software-defined WAN providers do a really good job at edge-to-edge coverage, so the edge of this network, the WAN deployed, software-defined technology on top to the other edge. But I think we all know that is not the entire network path. There is much more beyond both edges of the network that need observability. Understanding what the network experience is like to folks out in the field, especially supporting the mission. How is the network performing, and how is the user impacted, or how productive, the warfighter, how productive are they being? And then finally, zero trust. We're all implementing it now, but security solutions rely on the network. If the network isn't behaving and performing optimally, security isn't going to be performing optimally, it's going to be downtime, and there's going to be mission impact. So how do we get past all these challenges with this new network? We need observability. So network monitoring is much different than network observability. It's kind of like network monitoring on steroids. And again, monitoring was great for the old network path. Few hops, we knew every route, every packet, etc. But how do you begin to troubleshoot this when you may only manage a third of this network path? And the rest could be public or SaaS. That's what we're going to talk about today. And this is what the new network path looks like for the enterprise and the civilian or the government. All right, so the 5 ways, let's get into them. Well, the first thing we need to do is we need to accept the reality. The reality is that networks do not look like they looked 5, 10, 12, 15 years ago. Like I said, there's many network blind spots because we're adopting public infrastructure to deliver the mission experience over these networks. So we need to start understanding that this is the new reality and we have to adapt to it. And then once you say, this is my new reality, and what do I need to do to better manage it, you need to gather data. And if I was going to vote for one of the 5 things that I think are the most important in this deck, it is this. Data, data, data. The more data you have, the more insightful you're going to be, the more intelligent analytics that can be built and provide operators with root cause analysis and triage that makes sense, that makes their jobs easier, where they can find the root cause as quick as possible. So being able to collect logs and faults and alarms and events and performance and customer experience or the user experience. And when I say all that information, that needs to be applied to every part of that network path that we saw, whether you own that part or not. And obviously this helps you to become more proactive over reactive. Let the data do its job. Let the analytics that are on top of that data do its job. And there's topology analytics that can be applied to this, understanding the relationships and dependencies across that entire new network path. Again, if it's Verizon or CenturyLink, or SaaS, Azure, Google Cloud, you can understand the topology and relationships even within their networks, even though you don't have admin access to them. Event correlation and fault suppression. This goes back to the fact that networks can be very noisy and they produce events and they produce alarms and sometimes in the tens of thousands. So being able to have something that's smart enough to suppress and correlate that information and surface just the relevant alarm or event that the operator needs to work on. Of course, any anomalies in traffic, especially on the parts of the network that aren't owned by you, need to be understood. Volatility. This gets into more baselining and deviation from normal, but being able to understand if an interface is not behaving as we expected and looking at it over time and expecting something volatile to happen on the network that we can be proactive about. And then finally, one of the best things a lot of our customers at Broadcom talk about is the alarm noise reduction. So if you're reducing events because you're correlating them and rolling them up and producing and reducing the fault suppression, which is this switch net went down and it's got 7,000 devices connected to it. We don't need to know that the 7,000 devices are down. We just need to know that that core switch is down. So this is the type of information that gets suppressed, and then one alarm gets raised that the operator has all the information about to become more quick and more, to triage faster. Trust but validate. So a lot of the software-defined vendors out there today are building automation into their solutions where they're going to change the route according to the data that they get and push traffic over a different route. And that's all well and good. I mean, maybe the backup route has more bandwidth and that's what should have happened. But if that's not the case, you need to know about that. We can't expect the software-defined vendors to automate our network traffic without validating it and expecting the same results. So validation of what the changes have done, so we're still hitting our SLAs, is extremely important. This goes to applications, and if they're hosted here or hosted there. Active and continuous validation. That means continually monitoring and managing and putting packets out on the network in small packets to be able to continually measure latency, packet loss, and jitter across that link and how it's affecting the user experience. And then looking at it long term to be able to understand, can we proactively build this network out? Are we going to breach thresholds or SLAs 3 months from now? This is all information that is very relevant to observability in this space. And you're not done with that. I mean, it's a never-ending job of continually making sure that a ISP route that changed isn't affecting your warfighter experience, your user experience, understanding how they change things in cloud providers, and does that change the way your workers are doing work? Good example, probably a couple years ago now, I'm on the East Coast. I think it was an Amazon outage. Right before myself and my team were going to put out a press release about something big. And you have all these to-dos you got to do. Tweet this and send this email and blah, blah, blah. Well, what I didn't know is that one of the applications we used to do that task was housed in Amazon. I mean, I didn't know. It's just, hey, log into this and start doing that. You don't even think about it anymore. Amazon went down, and we were down for an hour. And so for an hour, we could not announce this new big statement within our company to our customers. It was miserable, to be honest. So being able to proactively understand or see when an outage occurs quickly, even in an unmanaged network, and then making changes. This is how we eliminate those blind spots. This is how we build observability into our practices. And then this is what you end up with. I mean, the slide I showed you before, 2 and 3 were grayed out because those are public environments that we're not gods of. We're not the lead admin for. So and I'm going to show you how we do this. So being able to understand the full network path, wherever it starts and wherever it ends, and then being able to pinpoint the device, the culprit device, and what's happening with it. So in this illustrated example, this device inside of a public ISP is having data loss that breaches a threshold that we set. Now granted, for demo purposes, I set it to 2. That would not be a threshold you would probably be setting so low, but as you can see, we've isolated the culprit device. Now, are we going to fix it? We're going to fix this device if it's in Google Cloud? Of course not. We're not going to fix it. But imagine the time it would have taken operations to not only look through this network needle in a haystack to find a device that doesn't belong to them and the exact data loss that it's happening. They could have spent hours in the war room blaming the app team, blaming the infrastructure team. This is game-changing for the way we run networks today. So I mean every hop, and I will show you. To understand the way packets move from cloud providers or from SaaS providers to DISA, to the analysts, maybe via satellite, out to the warfighter, and every single hop in that path to understand how resilient every single hop in that path changes the way we triage and troubleshoot today. It improves. I mean, I know customers that are talking about 90% improvement in triage times, 95%. They go from hours to minutes. It's actually doable. Didn't think this was going to be in there. So let me give you a real-world example of why it's important. So this is my kid's car. and I was replacing at the time her 4th bumper. And I told her, next time it happens, you have to deal with this. You call State Farm, you deal with it. I can't be replacing these bumpers all the time. So, with all the operational blind spots that we talked about, with the fact that we're using applications in the cloud, and maybe that State Farm agent is at home, which is a very strong possibility, that she's in the remote workforce and she's handling claims at her house. If my kid calls her and says, or him, hi, I need to put in a claim. What if the customer representative said to my kid, I think I'm having Wi-Fi issues at my house, or I think I'm having ISP issues in I can't get to the claim app in Azure or Google. That can't happen. It cannot happen. We would go to another insurance agency because the State Farm IT team is responsible for the entire network path from that customer service agent's house, from her home Wi-Fi, through her, let's say, Verizon Fios residential, out to however many ISPs that may cross, and then finally into Google where that claims app is. We are responsible for that entire network path now. Do you think the IT team at State Farm has admin rights to Google infrastructure? No, they don't, but they're still responsible for it. So this is what we're trying to solve. Now, I'm about to buy her a new car because she just graduated college and she's starting a new job, and I did sit her down and have a talk about all the bumpers I don't want to replace anymore, so. All right, let's see what this would look like. Let's see what end-to-end network observability looks like from a triage standpoint. So operations can understand exactly what's happening, where, and why. So, unified network. I mean, I can understand, again, to be able to start from an alarm in a unified way, then be able to move from that alarm that has suppression of events and alarm noise reduction, to then be able to see from that alarm the easy insights of red, green, yellow, maybe be able to consolidate or understand and correlate underlay and overlay coverage for your SD-WAN environments. And then finally being able to drill down into the exact network path and what it looks like. Exactly every single hop from start to finish. This is really the good stuff right here. And then like I showed you, being able to pinpoint the one device, and I'll show you exactly the ISP that this is a culprit of, isolating that one device inside of a public network to be able to understand, I have no idea why this is animating like this, the root cause of the issue. So, and this is unified network. To be able to have in one place easy insights into the overall network health across the globe, being able to move from an alarm console with one alarm that was built from tens of thousands of events that occurred, having standard operating procedures like ping and traceroute and telnet and all that inside of this console to be able to actionably understand and troubleshoot from this alarm, to graphically being able to see what do the links look like around the world, what's red, what's yellow, what's green, and then clicking on that link, the troubled link, to be able to understand all the relevant data on the right-hand side, and that's why data is so important. You may not be able to see it, but you're looking at system health and SDN metrics and reachability and interface, alarms, logs, telemetry, tunnel performance. This is all the data that's needed to confidently have a solution say, we know what the root cause is. Baselining and thresholding, that's always important to be able to understand how is this performing 3 months ago, how's it performing today, and how it's going to perform 3 months from now. That opens yourself up to optimization areas, re-architecting the network if need be. And then finally, again, what is the root cause? Pinpointing with these diagnostics along the entire network path, this is the device that's having packet loss, latency, jitter, et cetera, that we believe is causing the outage. This is unified network operations. So I know a lot of folks out there know Broadcom bought VMware. Has anyone heard of that? Yeah, yep. So I wanna like if you're scared, I want to like bring you down a notch or two. There's a lot of exciting innovation happening between both of us. VCF, that's VMware Cloud Foundation, building your own cloud inside of your data center. We are working with this solution, along with our network observability solution, to be able to manage the entire VCF, private cloud network path. But that doesn't mean just that. That means outside of that, it's just another technology for us. So you can monitor the base, you can monitor in the field, you can monitor in your private data center, and that can actually go out to maybe another VMware Cloud Foundation instance you have in AWS, and everything along that path. So providing visibility for the entire network path for VMware Cloud Foundation, on-prem or in the cloud, is what we're doing. VeloCloud, which is VMware's SD-WAN, which I'm sure folks know about. SD-WAN is very hot right now, but it's very, very complicated. This is a quick triage and workflow of how we're innovating with the VeloCloud SD-WAN solution inside of VMware with the network observability solution. Again, starting from an alarm, and then from that alarm, understanding the geographical health of those WAN circuits, and then discovering the entire network path of that entire instance that we're talking about. Diving deeper into flow or packet loss or latency and jitter, which is what a lot of WAN architects need to see. Understanding overlay and underlay correlation. How's the physical infrastructure behaving as it is hosting the virtual infrastructure? And then finally, getting to the root cause. This is data loss, and you can see exactly what's happening when it's happening. So you always should start from an alarm, and then being able to drill down to the root cause as quick as possible. And then innovating with the VMware team at Broadcom to understand more about observability inside of the ISP and cloud providers, even if it's cross-cloud. So again, starting from an alarm and being able to see the entire network path and find the root cause. Before I get into a demo, I just want to let you know, a little fluff here. I'm not blowing smoke. 4 years in a row, we're voted #1 in the leading analyst reports that do network observability. I expect the EMA report coming out in October will be #1 again, and voted #1 in user areas like PeerSpot, which used to be IT Central Station. So we're very proud of this. The analysts see the innovation that we're doing, especially with extending our observability outside of the four walls of the data center into ISP and cloud environments. All right, let's get into a demo. I'm sure this may have logged out when I click on something, but we'll see. All right, so what you're looking at is our observability solution as it pertains to the entire end-to-end network path experience. So like most companies and most agencies out there today, they need a very high-level dashboard that shows them if they're keeping up with their SLAs, what's good, what's not good. You can see we have some violations here. Let me see if I can make this a little bigger for you. We have some data loss, right? Some jitter loss. So we're going to dive into that real quick. So being able to understand at a glance what's wrong. I see that right away. Being able then to understand what the entire network path looks like for that specific application or user. I mean, this is real life. Look at the different routes that we could be taking that we have no idea when they're changing over in the middle of the night, during the middle of the day. This is what the new network looks like. It's very complex. We don't own most of it anymore. And this is what we need to be able to pinpoint. I mean, if I change this to the last day, I don't even think I can fit all the network paths on my page here. I mean, this is, yeah, I can't. I mean, it's just insane. The amount of changes that can occur in public networks that we're relying on to deliver our customer experiences. So we're giving you insight into that now. We can also understand, not from a hop perspective, but from a provider perspective, you know, who is delivering this traffic once it leaves us, right? I mean, in this case, this is a cloud-to-cloud instance, but coming from Google Cloud, going through CenturyLink, and legacy Quest. So we understand the ISPs involved in delivering this information. So now we're getting closer to understanding all the parties involved that's delivering this experience, but we're having an issue with it, right? And then from there, we want to look at the timeline. So what's been happening across the network over time that we have this SLA breach, right? So we're able to understand quickly and easily, I know that might be small, quickly and easily being able to understand route changes, ASA changes, packet loss, latency, and jitter over time for this specific network path. Again, we're able to understand who owns it, from Google Cloud Denver through CenturyLink, through Microsoft Azure, and then finally to the endpoint inside of Microsoft Azure. And this is now where we get into the diagnostics, to be able to really pinpoint across this entire network path what the issue is. You're looking at capacity here. We see we have a drop in capacity around this time, right? We had much more capacity before that. We see a bunch of data loss, measured data loss. Again, it's set to a low threshold, but it is breaching our thresholds. A lot of latency that is not behaving the way we should, and some voice loss. We can also look at this from a baselining point of view. So being able to understand, are we breaching the baselines that we set, the thresholds that we set to get alerted? As we can see here, capacity went very high for this link over our threshold. You can see we're breaching thresholds here with these spikes in data jitter. So to be able to understand and get alerted on very specific situations that you can monitor and set thresholds on, so you can be more proactive in the future. If this is always going to happen, we probably want to add more bandwidth. We probably want to set our thresholds a little higher, or we need to fix the issue. And if we run diagnostics, or look at the latest diagnostic that was run, and I mean automated diagnostics, that's that active, continuous, end-to-end continuous improvements you're making. This is you understanding what the resiliency is of the network path from end to end by injecting small packets and measuring them. So we can see here, for our entire network path, the issue seems to be in Quest, old school CenturyLink. So they have a device with this IP address that has data loss. And that is why we are seeing issues and why we're breaching our SLAs. Again, I can't log into this device and fix it, but I may have spent hours trying to figure out it wasn't us, it was them. This is what we call mean time to innocence, mean time to insights, where if I can prove it's not me, it's you, in minutes, imagine the time it saves when it comes to triage and troubleshooting. And then finally, it's not just about the network. It is also about how the network is delivering the user experience or the application. So this is an APM, it's not APM. This is how resilient is the network as applications are used on it. So as you can see, we look at many things synthetically, like opening a home page, logging in, clicking on this, clicking on that, logging out, and you can see the time it takes to do each step. And if that is going to breach a violation or a threshold we set for user experiences, this is something we want to know, and then tie it back to where it is in the network. So listen, if I was, let's say the State Farm claims agent was using this is the claim app and they were using it in Google, I'd be able to understand that maybe one of these timed out, and that's why she wasn't able to get to the claims app in the cloud provider. So right away, I don't own this part of the network, but I can see that this device in CenturyLink is having packet loss and logging in is timing out for users. I mean, I think that's gold, but especially when it comes to operations. So I think that's it for me, and I may have gone too fast, but listen, we're having a virtual summit next month, September 10th. It means you can watch it from home. We have healthcare, we have financial, we have folks from Google going to be there. If you want to sign up for the event and understand more about how we're helping the enterprises and the government out there with this exact solution, by all means, scan it and sign up. I think it's only 2 hours, so not a huge time out of your day. Did you get it all? And then if you want to read more about the solution, you can hit that and download a little 2-page solution brief. And if anybody wants to get in touch with me and talk a little bit more, by all means, hit me up on LinkedIn. And I'm happy to take any questions you might have now. I solved all your problems. Nice. All right, folks. Yeah? Yeah.
When it's running, is there a performance? Oh, thank you. The question was, is there any kind of performance overhead that this places on the network?
Yeah, really good question, because when I talk about injecting packets on your network, that probably might scare the hell out of you. I don't know the exact KB number, but it's in KBs, the amount of packets that we send. Very short spurts of packets to measure latency. And it's not noticeable at all. Not noticeable at all. Any other questions? Oh, we got one.
I will scan the QR code.
Great.
So I just wanted to make sure I understand that is this more of a suite that encompasses user experience, logging, maybe some app management or app detection anomaly? So it's a complete package of it's a complete suite. Yes.
It's a complete suite, but the suite includes network faults, network performance, network flows, everything that I just said inside of the four walls of data center, and then applied to outside of the four walls of data center into ISP and clouds. And what I just showed you is not APM, but it's more our diagnosis of how the network is behaving as it relates to application usage. Is it taking them 2 seconds to log in because of that data loss and that switch? Okay. So it is a complete suite and integrated. But I just don't want to lead you on. It's not APM, though.
Well, Lord knows the world does not need another APM package. Thank you very much.
All right, thank you. Thank you. All right, thank you, guys.